Suppose the commuter trains of a public transit system have a waiting time during peak rush hour periods of 11 minutes. State the random variable. The characteristic of interest is the waiting time. And assume the waiting time is uniformly distributed. So that would mean that between 0 and 11 minutes, the train is equally likely to arrive within that time frame, or you're going to wait between 0 and 11 minutes, and you're equally likely to come at 0 minutes or at 11 minutes. And they say, find the probability of waiting between 6 and 7 minutes. So to find that, we have to find the area under this uniform distribution curve, which is a straight line, between 6 and 7. So the probability that the train will arrive between 6 and 7 is the area under the curve here. And this area happens to be a rectangle. And we know how to find, hopefully you remember the equation to find the area of a rectangle. It is just the base of the rectangle times by the height of the rectangle. Or you may have said width times length, but the long side times the short side, okay, the rectangle. The base is to find the base, you have to measure this length right here, you have to take the endpoint, so the 7 and the 6, and you have to subtract them to measure how long that width is between 6 and 7. So the base is 7 minus 6. The height, this one is a little bit more complicated. To calculate this height, you actually have to calculate the height, or f of x, what they call f of x, which is the height of the function. And to find that height, you have to think about this whole uniform distribution. Over the entire uniform distribution, the area under that curve has to equal 1 whole. So that means when we calculate the area using the base times the height of this green rectangle, it has to equal 1. So the base is going to be 11, and the height we have to find out. So the base of this large green triangle that spans over the entire uniform distribution, that is 11, that just we subtract the endpoints, just like we did for the smaller shaded rectangle, 11 minus 0 to find the base. And then the height, we don't actually know, we know nothing about this height, we call it h. But we do know that because the probability under the uniform distribution over the entire interval has to equal 1, I do know that the base times height here has to equal 1. So 11 times h will equal 1. And then we can divide by 11 on both sides. And we find the height has to be 1 over 11. So a shortcut here is the height of the uniform distribution is always equal to 1 over the length of the entire uniform distribution. So this was equal to 1 over the length of the entire uniform distribution. You know, because they said it could be, it's uniform distribution between 0 and 11. Or the base of the entire rectangle, the uniform distribution. So that's our base our height of the distribution. So that's the same as our height for this shaded rectangle will have the same height. So that's why we're going back to finding the area of this shaded rectangle. Well, the base we already found is 7 minus 6, which is 1. And then the height is the same as the height for the big rectangle over the entire distribution, which is 1 over 11. So 7 minus 6 is 1 times by 1 over 11 is just 1 over 11. So that first answer is just 1 over 11. We could round that. You could round that to 4 decimal places. It may want you to. Okay. For this second part, we already know the height of this distribution, so we don't have to do that calculation again. So we don't, all of this stuff in the green up here, we don't have to do. We already found the height of the entire distribution, and this is now just asking us find the probability of waiting between 7 and 9 minutes. So the only thing that's going to really change is the shaded rectangle. So instead of between 6 and 7, now it's between 7 and, well, I said that was 7, just stay consistent, and 9. So we have to find the area under the curve and above the x-axis of the rectangle between 7 and 9. The base, and we're still going to use area equals base times height. The base is 9 minus 7. It's the 2 endpoints of the rectangle subtracted. The height is the same height that we found in the first problem. So it's 1 over 11. So it's still 1 over 11 for this whole distribution. So then we get 2 times 1 over 11. Which equals the final answer. And I always can put 2, the whole number over 1. So it's 2 times 1 in the numerator is 2, and then 1 times 11 is 11. So it's 2 11ths. That's the answer for that second one. Okay. Next, they say find the probability of waiting exactly 7 minutes. So let's try to draw the area of, let's try to draw that rectangle. All of these we know are the same. So I shade 7, but it's exactly 7. So I just draw a little straight line over 7, and I ask myself, what is the area of that straight line? Well, there is no area in a straight line. So the answer there is just 0. And this last problem is just a reminder to us that it only makes sense to calculate probability for a continuous random variable. It only makes sense to calculate the probability over an interval. So it can only make sense to do between 6 and 7, or between 7 and 9, or on some interval, but it does not make sense to find the probability of exactly a particular number. And whenever we're dealing with a continuous random variable, when we find a probability of exactly one number, that probability is always 0. And it's because, like I mentioned, there is no width to that rectangle, so it has a base of 0, so it would have an area of 0. Okay, bye.